All right, here we go with radioactive elements. Okay, so just a little review here. Remember, a proton and neutron are in the middle of an atom, and what's outside are electrons, and that these things have different charges. Okay, so keep that in mind during our lesson today. Here's your learning targets. Your first one is to explain how neutrons affect an atom's stability. So thinking about the neutrons in the center of an atom. Okay, so first off, you need to know, right, the number of protons is what defines what element an atom is. So for example, right, an atom that has 6 protons is always going to be carbon. But carbon atoms can have different amounts of neutrons or electrons. They just can never have different amounts of protons. Okay, here's another example. So these are 2 different versions of oxygen. This one on the left has 8 protons and 8 neutrons. And this one on the right has 8 protons but 10 neutrons. Okay, they're both oxygen atoms because they both have 8 protons. That's what makes an element that element, the protons, okay? But you can have different amounts of neutrons. All right, here is another example of helium. So here, protons are blue. So this helium atom has 2 protons, and this one has 2 protons, but this one has another neutron. So again, still the same element, just different amounts of neutrons. Okay, what does this have to do with radioactivity? Well, you'll find out. You're not going to do this activity because this is a review video. But basically, we made a little graph. Okay. And the graph that we made in class looks kind of like this, but it was much simpler. But basically, it was showing this, that if you make a graph of different atoms, and on the bottom you have the number of protons, and on this side you have the number of neutrons, you'll start to see, like, in the middle of the line, that's where atoms are stable, and on the sides are where they're unstable. Okay. So I think actually I'm going to show you a simulation here. Hold on. Okay. So here we have our little simulation, and I'm going to make a couple different atoms. So I'm going to put a couple protons in the nucleus. I'm going to start putting neutrons. Okay, so when an atom is stable, it'll tell us right down here. But at a certain point, if I add too many neutrons, the atom becomes unstable. Right? And in this case, you'll see if there are too few neutrons, the atom's unstable. If there's... Oh, this is not a good example. Hold on. Okay, here's lithium. Okay, if there's not enough neutrons, the atom's unstable. If there's, like, a good amount of neutrons, it's stable, but at some point, if you add too many neutrons, it's unstable again. So the main point is that atoms become unstable if there's not enough neutrons or if there's too many neutrons. So either way, okay, it's kind of like, let me think of an analogy. If you're hungry, if you don't eat enough food, you're still going to be hungry. If you eat too much food, you're going to feel sick, right? So you have to eat like a certain amount of food to feel stable. Otherwise, you'll be like hungry, unstable, or too full, unstable. Okay, so what happens when atoms are unstable? They actually break apart, like physically break apart. This is the nucleus of an atom. So part of the nucleus, so some protons and neutrons actually break off from the rest of the nucleus. And this is what radioactivity actually is these pieces of um, the nucleus of an atom breaking off. Okay. And we call that radioactive decay because the nucleus is actually decaying into smaller pieces. So radioactive decay, there are three main types: alpha, beta, and gamma. We're just going to focus on the first two for right now. Okay. So during alpha decay, two protons and two neutrons come out of the nucleus. During beta decay, one of the neutrons in the nucleus turns into a proton, so it actually gains a proton. So in this first example, alpha decay, it loses protons. In beta decay, it gets protons. Okay. And it also loses this thing called the beta particle. It's actually just an electron. You don't need to know that. Okay. So here's a couple examples. Oxygen. There are radioactive versions of oxygen. They're not common, but there are. It has 8 protons. Okay. If it lost 2 protons because it went through alpha decay, now it has 6. Okay, so now it's a different element, right? Because remember, the number of protons determines which element an atom is. So it was oxygen. Now, if you had a periodic table, you'd be able to look at it and say, okay, it had 8 protons, now it has 6. Now it's carbon. Okay. Okay. So those are kind of the two main types of radioactive decay. We're going to talk about the last one in a little bit. But this breaking apart of the nucleus, this radioactive decay, atoms can actually go through this process many times. So they don't just go through it once, but many times usually. Here's an example. So uranium is radioactive. And let's say a uranium atom goes through alpha decay. Okay, so it loses 2 protons. Pew, there it goes. When it does that, it turns into the element thorium. Okay, now the thorium atoms in this hunk of rock go through beta decay, which remember means they actually get a new proton. So, boop. gets a proton. That changes what the element is in this rock. So now it's the element protactinium. And protactinium also goes through beta decay, and it gets a new proton, so it turns into a different element. Okay, and this happens over and over. This is what this graphic is showing. So the element uranium, right, it's radioactive, it's unstable, it goes through this decay process, turning into a new element every time, and look at how many times it does this. Okay, so this takes many, many years, billions of years, in fact, but eventually uranium will become lead at the end of its life. And then lead is not radioactive, so it won't break down anymore, and it just stays lead. Okay. Every time one of these changes happens, energy gets released. So, bam, uranium turning into thorium releases energy. And then thorium turning into protactinium, energy gets released. Okay, and this energy is, it has to do with what we call gamma emission, which is the last type of radioactive decay. All right, so here's our example. Uranium is radioactive. The nucleus breaks apart. It goes through alpha decay, which means it loses 2 protons and 2 neutrons. It turns into thorium. When that happens, anytime alpha decay or beta decay happens, something called gamma rays come out of the nucleus. So this is showing gamma rays. It's like invisible energy. And we call this gamma emission because gamma rays are being emitted from the atom. Now, gamma rays are a form of energy, and they have very high energy. So these are like the different types of energy in our universe. We have radio waves, infrared waves, UV rays or ultraviolet, and gamma rays all the way over here. They're the highest form of energy. Okay. And so you got some high energy coming out of these radioactive atoms. And here's our 3 types of radiation: alpha, beta, and gamma. Okay, alpha, beta, gamma. And they're a little bit different from each other because alpha particles, they can be stopped by a piece of paper. They're a little bigger than the other forms of nuclear radiation. So you could put a piece of paper in front of you and it'll stop those alpha radiation particles from getting through. Beta can get through paper, but it'll be stopped by aluminum. And gamma rays, the highest form of energy, they can go through these things and actually can penetrate a thick wall of lead. So a lot of times when we talk about things being radioactive, it's really the gamma rays that we're concerned about. But alpha and beta particles, we can worry about if they get into the air or like our water supply or something. But usually it's the gamma rays that we kind of consider the most dangerous, I guess. Okay. I think that is it for our slideshow here. If you like videos, check this one out. It's pretty awesome, by Veritasium YouTube channel. He'll visit some radioactive places on Earth. But otherwise, you can finish your notes page and you're done. Good job.